In the question above, we are being asked to calculate the grams of bromine that will be required to completely react with 10 grams of propyne. And for that kind of reaction, that means propyne will be undergoing addition reaction. So since propyne is an alkyne group with triple bond, for it to undergo complete reaction with bromine, that means it wants to change from triple bond to a single carbon bond, and that will take a step. It will be a step-by-step reaction. That is, to change from alkyne group to alkene group, then from there to alkane group. That is, from triple bond to double bond and then to single bond. So the first thing we'll be doing now is to show the step-by-step reaction, and we'll be by writing out the chemical equation of each step from which propyne will be changing its bond for complete reaction with bromine. Let's start. So propyne has the chemical formula of C3H4. When it reacts with bromine, we have C3H4Br2. This is an alkene group. So from this double bond now, it will still undergo another reaction because it is said that it is a complete reaction. We have C3H4Br2 reacting with bromine again. Then this will give us C3H4Br4. So the number of atoms of bromine is now becoming 4. So looking at this, let's combine these steps, that is the first one and the second one, to have a single equation that we'll be working with. So combining this, we have C3H4, that is propyne, reacting with bromine, B2. So we have 2 moles, the first one and the second one in both steps. So we're having 2 here as the coefficient to give the product, which is C3H4Br4. And this will be the final equation we'll be working with. Now going back to the question, we have to determine the mass of bromine, and we are being given the mass of propyne. And the next thing to do is to calculate the reacting mass of each of the compound that take part in the reaction. So we need to calculate the reacting mass of propyne and that of bromine. Then from there we'll use the relationship to determine the mass of bromine that will be required if we have 10 grams of propyne. So let's proceed. To calculate reacting mass, we'll be using the formula that says number of moles multiplied by molar mass, and we need to determine the molar mass of propyne first before we can proceed. Why the number of moles will be gotten from the coefficient of the substance in the equation written above, and the coefficient here is 1. For bromine, the coefficient is 2. So let's proceed. Molar mass of C3H4, that is propyne, that will be the sum of the atomic masses of each of the elements present. We have 3 atoms of carbon, and the atomic mass of carbon is 12, so 3 times 12 plus atomic mass of hydrogen, that's 1, 4 times 1, since we have 4 atoms present. Calculating this, we have plus 40, the unit grams per mole. From the reacting mass will be the number of moles, and from the equation, as earlier said, we have that to be 1, multiplied by the molar mass we've gotten from our calculation, that's 40. Calculating this, we have 40 grams. So let's solve for bromine as well. Molar mass of bromine. Since we have 2 atoms present, that will be 2 multiplied by the atomic mass of bromine, which is 80. And this equivalent to 160, the unit grams per mole. The reacting mass as well, the number of moles, from the equation we have that to be 2, multiplied by the molar mass we've gotten from the calculation, 160, the unit grams per mole, equals 320 grams. So we've gotten the reacting mass of each of the substances involved. So let's proceed to determine the mass of bromine that will be required. You can then say that 40 grams of propyne, according to the calculation we did, will require 320 grams of bromine. So if we have 10 grams of propyne, X grams of bromine will be required. X, we are using X because it is an unknown. So from here we solve for X by cross multiplying and making X the subject. So from here, X equals, cross multiplying indirectly, we have that to be 10 grams multiplied by 320 grams divided by 40 grams. Calculating this, we have 80 as our final answer. So with this, we've come to the end of the solution of the question, and we've gotten the mass of bromine that will be required to completely react with 10 grams of propyne to be 80 grams. That will be serving as the final answer. Do well to subscribe for more if you find this video helpful.